A good segue, I think, from Stuart in the last session. The problems and materials were a couple of main takeaways, and we're pleased to have Robert Hood here from Intelliwave, who's going to talk about materials management and AWP. So, take it away, Robert. Thank you.
Awesome, thanks. So I guess before we get started, just a little bit on myself. I don't do a lot of work in the UK, so I don't know everybody in the room. I'm sure everybody doesn't know me as well. My main role, I work in Intelliwave Technologies. Our end product, we offer software as a solution for supply chain management. My role within that kind of ecosystem is working with our enterprise-sized clients, whether EPCs, owners, really helping kind of realize these digitization initiatives that have come up in the last, like, say, 5-10 years. Everybody knows that, you know, Excel is not necessarily the best path forward, but no one knows how to elaborate from that. So it's kind of where I come into the fold. Right, so the panel questions, if you have anything at the end, there'll be a panel afterwards. So anybody who wants to scan the QR code, give you guys a couple seconds here. Our social media aspect. All right, so what I'm here to talk to you guys about today is materials management, how that kind of fits into AWP. So integrated engineering to procurement to construction. So I've already talked about myself. I also like to wear the same shirt that's in my picture so that everybody can identify me. So I want to start out with a couple of stats. So one of the biggest things, and I will, little disclaimer, these stats were published in 2021 from studies that were done in 2020. But at the time, this study found that roughly 95 or almost 96% of data captured on a project goes unused in engineering and construction. So it might sound like a big number, but when you think about it, how many emails you guys get in a day or on a project that you didn't need to see? How many pieces of sensors or technology or anything that's monitoring on a project, you know, captures data but isn't necessarily used? It also found that 13% of construction work hours are spent looking for data. So you can imagine, you know, small scale, if you have a company of say 100 people, right? Roughly 13 of those 100 people would spend their whole day looking for data. You amplify that to some of the mega projects that have 5,000 to 10,000 people a day, right? The numbers start to add up. And then it found, which is something I think a lot of people have been touching on here today, 30% of engineering and construction companies have applications that don't integrate. So what that means is you might have an engineering platform that doesn't talk to procurement. You might have a work-based planning that doesn't talk to materials management. And that's the way construction has been for eons. But it is something that AWP is trying to fix. Next, to accompany the unused data, we have bad data. So bad data being defined as inaccurate, incomplete, inconsistent, or untimely. So in 2020, right, we have construction accounting for roughly 13.2% of global GDP. If you look at the bad data as a percentage of that, it's attributed to roughly $1.8 trillion in losses. Okay. Bad data account for roughly 14% of all potential avoidable rework. And then 30% of participants claim that more than half their data is bad. So again, these numbers might seem large, but when you think about it, you can relate to any of the big projects, small projects you've been on, these numbers start to make a little more sense. Okay, so what we're here to talk about today in particular is how integrated materials management kind of solves and tackles some of these challenges. So a major one is obviously data from multiple vendors. We'll talk about like different challenges amongst that, lack of engineering data for planning, and then data coming from multiple systems. So challenge number one, data coming from multiple vendors. So on any given project, it is almost a guarantee that not all of your material will come from one vendor or one fabricator, right? Within then, you have different processes amongst the same vendors. Even if you have the same commodity, let's say you take steel, right? It can be fabricated in India, it can be fabricated in China, North America. Different vendors have the same process to fabricate the same material. With that, there's different data points that are captured, right? Whether it be, proprietary or trade secrets. If you look at QA/QC statuses, different material types have obviously different QA/QC requirements. Fulfillment statuses, shipment statuses. And again, all of this, again, is coming from multiple vendors. It can be across different languages. It's a lot to have to try to sanitize, if you will. And then we talk quality assurance, quality control. So again, even amongst the same material type, I'll pick on structural steel or pipe spools for this. If you get the material in China versus India versus North America, it's almost a guarantee that the level of quality assurance or quality control will vary depending on where you get it from. A lot of that is built into competitive advantage. Let's say you get something fabricated in China, typically there's, the competitive advantage is cheaper. There's an accepted rework or amount of material that you expect to have to either scrap or get done locally. In addition, different material has different QA/QC requirements. Not only just that, but geographically, right? Again, I'll pick on China, for instance, the quality assurance levels within China may be different than the quality assurance like minimums of, say, North America. So solution, or part of the solution to problem number one. So engaging the vendor, active vendor management, vetted quality assurance and quality control. So one of the big things here is ensuring at a minimum, obviously where the project is being put together, that those quality control measures are met. But oftentimes as an owner, as an EPC, as a client, your own QA/QC requirements will supersede that of the vendors. Ensuring that the vendors meet those minimums will go a long way to mitigating rework, that kind of stuff. Contracts and scope of work that obviously clearly define documentation requirements, mandate minimum acceptance criteria, and obviously constant communication. Engage early and often. Part of engaging the vendor, for mega projects may include having your own personnel at the vendor facility to ensure that your QA/QC processes are followed. Clearly defined documentation. This might be, at a minimum requiring, material test certificates, standard operating procedures, MSDS material, right? Something that is commonplace or what you think would be standard isn't necessarily standard from vendors in different parts of the world. Being upfront about that goes a long way to mitigating, again, rework, looking for information, all those different types of things. Second part of the challenge, material identification. So this is it sounds like a small problem, but it goes a long way. One of the things that we talked about was roughly 13% of time is spent looking for data. So a lot of times when you buy something from a vendor will identify that material with some in-house part name or SKU, which is different than you have in your model, which is different than you have as a tag piece material for your plant or your facility. And oftentimes what happens is, that packing list of material shows up, your warehouse laydown crews, they look at it, it does not match the model. And then they go, there's RFIs, they're going back to the vendors to ask for what parts these are. So material identification can cause a lot of heartache. However, it can be, solved partly with vendor engagement, but also we're going to talk about it in a second here. Oftentimes engineering tagged items, so one of one, are not necessarily as big of a problem because they can only be named one thing, they can only go in one place of the plant. Commodities become a problem, right? So if we look at something like a valve, which typically, it's a tag in practice, but at the same time, a valve is a valve, right? Your spares will be identified as a commodity. So being able to distinguish between tagged items, commodities, becomes a lot. So how do we solve this? Well, one approach is to standardize vendor data. So part of this is, visibility into vendor processes and systems. So standard progress updates, status reports, material identification standards. So for instance, dictating ahead of time, and a part of this comes with vendor engagement is collaborative contracting, right? Working with your vendors to ensure that at a minimum, it's in their scope of work to identify the material with project nomenclature. Client and project confirmed packing lists. So again, ensuring that before material is shipped, it is properly identified, properly labeled. You don't know how many times that material shows up, it doesn't have any type of identification, right? That stuff goes into quarantine, there's a whole process to properly identify it. All these things, again, can be mitigated up front. Right, and all this contributes to that 13% of time, spent looking for data. Challenge number 2. So engineering data. And I actually want to touch on something that Stuart mentioned. If we look at this materials management lifecycle, so in the middle is your typical, procurement lifecycle of material. So we have obviously the procurement aspect, T&L or shipping and logistics, receiving and inventory maintenance, picking and issuing. But what are the inputs into the procurement? Obviously you have, engineering, which determines what needs to be bought. You have advanced work packaging or advanced work planning, which determines when the material is actually going to go into the plant. And then you have construction, which actually, needs the material and carries out what the AWP is mentioning. Stuart brought up an interesting point of a project, and I don't want to wrongly quote the number, but at least it's 700,000 Excel spreadsheets. So if you look at this being like a more siloed approach, those 700,000 spreadsheets may be in engineering, they might be in construction, they could be in AWP, they could be in shipping and logistics. The problem is amongst those 700,000, not everybody has access to them. They can be sitting on someone's desktop. It could be the piece of information that your construction teams need, right? So how do we solve this? Well, we integrate them. So basically, we put everything into one nice, convenient ecosystem. So engineering talks to procurement, shipping, logistics, receiving and inventory, all fills into advanced work packaging or planning, picking and issuing, and then obviously you have construction. Now, amongst AWP, really AWP could be an input or an output to all of these things, right? I think AWP as an overarching philosophy is, it hits every aspect of the construction lifecycle. So AWP is obviously, an output of, receiving an inventory. It's also an input to picking and issuing, right? But it all aspects, of procurement. It tells, procurement teams what to buy. Engineering also. So one of the big things that, from an integrated perspective is just ensuring that all of the aspects of the life cycle talk to each other. Challenge number 3. So, and this is a big one. So multitude or lack thereof of softwares. I think everyone will be able to relate to this one. So a big thing within the first part of this challenge is when you have too many software or softwares at play. So a lot of times, for those of us who work in different aspects of a project lifecycle, right, we'll have our own specific software that we're aware of. So purchasing typically has one, right? ERP platforms. Transportation logistics will work in a totally separate ecosystem. They don't necessarily need everything that purchasing has. Their functionality sets are very different, so they don't necessarily use the same software. Materials management, then also different, right? Materials management typically only kicks in after the transportation logistics, but doesn't have to. But the functionality sets amongst all of these are very different. And often what happens is all of these different disciplines within a project will utilize a platform that is very niche and tailored to their use cases. Oftentimes, a lot of data from one ecosystem or one discipline is not needed in the other discipline. It's very hard to find one platform that will do everything properly. In addition, right, we have also vendor-specific software, which can be an in-house solution. So a lot of times, a value add of a particular vendor is proprietary software. So not only are they the only ones that can use it, they're the only ones who have access to it. Is it third party? Is it something that is new to a project? Is it new on the horizon type of thing? And then the exact opposite of that, which Stuart touched on also, and we can think of Excel, is the lack of software, right? So the absence of a formal solution. You might think in 2024 that pen and paper is the way of the past, but As an account manager who works strictly with enterprise level owners, I can tell you that it is actually amazing how many like the Fortune 10 owners of the world still use pen and paper for construction, right? A lot of times this can come down to construction being adverse to change, right? You get a lot of people who work in the construction industry, not to pick on them, but a lot of them have been doing it for 40, 50 years the same way, right? They don't need to learn how to do, to use a piece of software to install a piece of structural steel, right? So for them, it is, it's a mitigation, but it's also like this adverse like approach to change. And with that, you get, like I said, a formal lack of software. So solution number 3, what we like to call the single source of truth, right? So in our platform, this would be a little pitch for us, but basically what we look at is when we look at a single source of truth, it's not one system or one piece of software that does everything. It's really a collaborative digital ecosystem that just provides visibility to all of the stakeholders. So for instance, when you look at purchasing or an ERP platform, it's not necessarily going to be the best like workplace planning platform. It's not going to be the best materials and inventory management platform. But at the end of the day, what you can do is you can utilize a system that integrates all of those individual softwares together into one convenient to use tool, so that any aspect of construction, any discipline that needs that piece of information can obtain it through a single platform without having to log out, log back into another ecosystem type of thing. So basically enhancing visibility of project material through the entire life cycle. So obviously we have a couple of the aspects here: design, fabrication, expediting and shipping, that might fall under procurement. Right? Site materials management, requesting and issuing, workplace planning, that falls into another. Commissioning and turnover, installation and testing, facility operations. Typically all of these small niches would fall into specialized software, and it still can live in those specialized softwares. But at the end of the day, it's nice to have this one ecosystem where, let's say your operations and you want to get access to all the preservation and maintenance related to one particular tag. It's nice to be able to log into that same system that you're using to track the fabrication of another piece, versus having all of these disjointed and siloed pieces of software. That's it for me. Yeah, I believe questions are going to be during the panel session, so yeah.
We do have a little bit of time, so.